Is it not still presentation one? Okay. All right.
Good afternoon, everyone. My name is Tomoe Nasuno from Jamstec. I would like to talk about relationship between tropical cyclone intensity and sea surface temperature based on sensitivity experiments using a global non-hydrostatic model. It is well known that the tropical cyclone intensity and sea surface temperature to the tropical cyclone intensity, sea surface temperature is a key parameter. However, in Western North Pacific, where the broadly warm SST anomaly exists, SST does not fully explain the intensity anomaly variability. Vertical shear of the horizontal wind have also great effects. And also, SST does not only affect tropical cyclone intensity in the beneath the tropical cyclone, but through the atmospheric responses to the sea surface temperature distribution. Typical example is the El Nino years. In El Nino years, the tropical cyclone tend to be generate in the southeastern part of the Western North Pacific and then traveled long time over the warm ocean, then gain a high accumulated energy. So, the objective of this study is to understand the influence of the sea surface temperature anomaly in the northwestern Pacific subdomains, sea surface temperature in the subdomains, not the typical ENSO type, but the more detailed structure. And we focus on, in this study, lifetime maximum of the tropical cyclone intensity. And our point is to look into the history that each tropical cyclone experienced from its very initial genesis to the timing of the maximum intensity, and examine the effect through the atmospheric responses as well as the SST. For this purpose, we conducted sensitivity simulations using global non-hydrostatic model NICAM, ensemble simulation of 24 members for each case. We look into the 2018 case. This year, the sea surface temperature anomaly has warm anomaly in the tropics, central to eastern tropics and central Pacific subtropics, and in the mid-latitude. Then, in this situation, tropical cyclone activity was above normal over the Western North Pacific. And in the sensitivity experiments, we replace the local regional tropical sea surface temperature anomaly, speak subtropics and tropics, and also the all area. Let us see the tropical cyclone tracks simulated in all the ensemble members for each cases. We can see that in the control simulation, the enhanced typhoon activity, especially in the eastern part of the Western North Pacific basin, is relatively well simulated. Without the subtropical warm anomaly, the active area of tropical cyclone is confined in the western part of the Western North Pacific and in eastern part suppressed conditions. Without the tropical warm anomaly, overall reduction of tropical cyclone activity was found. Then, when we look into this plot, it is seen that this is the histogram of the lifetime maximum intensity and frequency. And we see, as we expect from this plot, with the tropical warm sea surface temperature anomaly, relatively strong tropical cyclone is the frequency is larger. And this is the probability density function. And we found that the very strong tropical cyclone occurrence frequency is greater, even greater without the subtropical warm anomaly than the control simulation. With this in mind, we investigate the history of pre-storm sea surface temperature anomaly in each tropical cyclone track and take average of the every ensemble members, as well as atmospheric environment such as the vertical shear zonal wind, low level relative vorticity, and middle tropospheric motion, and some dynamic variables such as the pressure of water. This is a scatter plot of the history of pre-storm. We used the 1 day pre-storm environment or sea surface temperature. Then we see that the history of sea surface temperature is positively correlated with lifetime maximum intensity. And this color dot indicates the vertical shear. And we see that the intense lifetime maximum velocity appear with the weak vertical wind shear. So next, in order to compare the relative importance of these atmospheric conditions and sea surface temperature, we calculated the box difference index, which is defined by the difference between the mean value of two categories for each variable, divided by the standard deviation of both. Then the upper rows show the difference between the very strong tropical cyclones and weak tropical cyclones. Then we found in every sensitivity cases, sea surface temperature and experience of over 29 degree sea surface temperature is highest value, followed by vertical wind shear and relative vorticity for all the cases. So this is the same as our expectation. The lower rows show the difference between very strong tropical cyclone and the strong tropical cyclone. In this situation, the sea surface temperature showed high value, but the vertical velocity in the middle troposphere has comparable value as sea surface temperature in some cases. The cases with the high relative value in the middle tropospheric upward motion is without the subtropical warm sea surface temperature cases. Then next, we look into the vertical middle tropospheric vertical velocity distribution and the location of the lifetime generation of each vortices and lifetime maximum location, red circle, for the tropical cyclones exceeding for 40 meters per second, strong types. And then we see this is the relative ratio of the anomalous vertical motion from the area mean vertical motion. Then we see upward motion, relative upward motion in the southeastern flank, and many of the strong tropical cyclones generated here and travel individual paths along this and reach the location of the maximum intense area. So in this case, the which route they pass over affects the vary with the route, the experience of the history of vertical motion, environmental vertical motion. This is the control case, and this is the subtropical climatology case. And we confirm that in the case of control case, the difference between these zonal, the path of each tropical cyclone may more smaller than this SP cream case. In this case, the difference between among the vertical motion which the tropical cyclone may experience is much greater than the control one. So, associated with the vertical motion, in the SP cream case, the subtropical high is stronger with stronger subsidence in the subtropical domain. And then the favorable moist condition is confined in the western part of the western North Pacific. Although in contrast, in the control simulation with the warm sea surface temperature anomaly, both in the tropic and subtropics, everywhere is relative moist condition. Then this upward motion and moisture does not make much difference in the tropical cyclone intensity. This is our speculation. This is the conclusion that the history of the preston sea surface temperature and followed by vertical wind shear is deeply related to the, in fact, related to the lifetime maximum intensity of tropical cyclones. But in some cases, such as the SP cream case, the clear contrast between the zonal contrast between the sea surface temperature anomaly, the vertical motion or humidity that each tropical cyclone may experience may affect the lifetime maximum. Thank you very much.
So thank you very much for the presentation. Any questions or comments from audience? No? So, if no, may I ask one question to you? So how about the number of the precursor of the disease? Did you find the sensitivity or the difference between the control and the SP screen for the number of the precursor of the tropical cyclones?
Number of precursor depends on the definition.
Yeah.
But all the tropical cyclone, varies, with, centered around 300 for each, cases for 24 ensemble members.
I see. But so the environmental condition for the SSD is pretty different between the control and the SB clean. So some kind of the convective activity should be different, the following that the condition. So I think about how many frequency of the seeding for the TC is affected by this difference. So yeah, I would like to discuss later. So
yes,
it's time. So I would like to move on to the next. Thank you so much. So the next